Lithium-ion batteries are extremely commonplace in the world today. These high-energy rechargeable batteries can be found in everything from personal electronic devices like your watch, your smartphone, cameras, power banks, laptop computers, tablets, tools, e-bikes, scooters, and even electric vehicles. And the forecasts show that the number of lithium-ion batteries out there will continue to grow over the next number of years. Lithium-ion batteries have become so popular because they can be made in different sizes and shapes, they can store a tremendous amount of energy, and they can be recharged over and over again. Unfortunately, this high potential for stored energy also can lead to a high potential for fire. Hi, I'm Chris Turner, Technical Advisor and Firefighter with Brimstone Fire Protection. Today I'm going to walk you through some of the basic information about lithium-ion batteries, how they're constructed, what precautions you need to take when using them, how they may start on fire if used incorrectly, and ultimately some safety information for you to keep you and your family safe. Now, we at Brimstone Fire Protection know that every battery incident is going to have a combination of multiple variables, so there's simply no single right answer to every incident. But we want to give you some best practice suggestions, some other recommendations, in a hopes that you'll be able to navigate a battery incident as safely as possible. Now, as I mentioned, lithium-ion batteries can be found pretty much anywhere you go, in your home, in your workplace, wherever you are. And unfortunately, because of the rise of lithium-ion batteries, we in the fire service are starting to see a rise in lithium-ion battery fires as well. And that's just the unfortunate reality of having such a high energy storage device. We hope that you'll never have to be face-to-face with a battery fire, but in the instance that you are, we want to give you some good information on how to navigate that safely. The owner of this home unfortunately had that interaction when he was charging some drone batteries on his desk. These were brand new batteries and it was the first time that he'd charged them. This amazing footage from his security camera actually captures the instance when the battery starts on fire. And unfortunately, it led to his entire home being burned down. Even more potentially scary is if there were a battery incident on a plane when you simply can't run out the door and get away. According to the FAA, there have been almost 700 incidents with lithium batteries involving smoke, fire, or extreme heat since March of 2006. In 2024, there were 89 incidents compared to 45 just 5 years prior in 2019. There's no limit to the number of batteries you can carry on board a plane, as long as they're installed within a device and they're 100 watt-hours or less. There's also no limit to the number of spare batteries you can bring on a plane, again as long as they're 100 watt-hour or less and in your carry-on luggage. You should never pack spare lithium-ion batteries in your checked luggage. With airline approval, passengers also may carry 2 spare lithium-ion batteries in the 100 to 160 watt-hour range. Let's take a look now at the different battery types that are out there. When we look at different devices, personal electronic devices and tools, all sorts of different rechargeable items, we usually find the 2 main types of batteries are a cylindrical cell, like this one, or a pouch cell, like these 4 here. They're essentially a similar design in that they have 2 electrodes and electrolyte within them, separated by some polymer separators. In the cylindrical cells, the electrodes are wrapped into a circular shape. The industry commonly refers to this as a jelly roll. Whereas in the pouch cells, those same sorts of materials are more laid in a rectangular flat pattern versus circular. And there's different chemistries from which batteries can be constructed. Different types of metals, different types of electrolytes, etc. But what we find is that they all behave fairly similarly. They all can release toxic and or flammable gas, and by and large, every electrolyte out there is still flammable. The battery industry is continuing to try to make safer batteries that are less prone to fire, but so far, all of the ones that have been made still have that fire potential. So of the devices I have here, I've got several that have pouch cells, like these personal electronic devices. I've got some that have the cylindrical cells, like these tools and this e-bike battery. And of course, because there are different sizes of items, they have a different amount of power. Now, the way that we can tell how much potential energy a battery can store is by how many watt-hours it is. On the battery itself, it may tell you the number of watt-hours. This e-bike battery is 270 watt-hours, for example, or it may tell you the number of volts and amps or milliamps. And watt hours is a simple calculation multiplying the amp hours times the volts. So your phone can typically range from 5 to 20 watt hours, for example. A tablet may range from 25 to 45 watt hours, a laptop from 50 to 70. Power banks like this one here can oftentimes range from 50 all the way up to 100 watt hours. Tools like the ones I have here oftentimes can range up to 200 watt hours. High-powered drones may go to 100 plus watt hours as well. Scooters can range from 250 to perhaps up to 1,000 watt hours. And as I said, e-bike batteries can also range typically 500 to 1,000 watt hours. When you compare that to a battery in an electric vehicle, you may be looking at about 5,000 watt hours or about 5 kilowatts per individual battery module. So how might a lithium-ion battery, or the device which houses a lithium-ion battery, catch on fire? There's a number of different ways this can happen. One is through direct heating. As you heat a battery, its internal pressure rises to the point where it will become corrupt and rupture, sending its toxic and or flammable gas out and causing a short circuit inside the battery. That leads to a fire very, very quickly. As the cell within a battery pack catches on fire, it becomes heated to the point of several thousand degrees. Other adjacent batteries in that same pack can then be heated, causing a cascading thermal reaction we call thermal runaway. In this example, you'll see I've taken 25 of these cylindrical 18650 cells and packed them closely together as they might be in a tool, for example. I'm heating the center one, and you'll see that the smoke starts to emit from that center cell, and as we continue to heat it, it will burst into flames. That's thermal runaway within a single cell. Now we have to worry about all those adjacent cells that are being heated from that first cell. And as you'll see here, that thermal reaction cascades through the remaining 24 batteries in pretty rapid succession. Oftentimes the battery fires we see are while the battery was charging. Sometimes this is due to a faulty battery, sometimes it's due to a faulty charger, or sometimes the people that are charging the batteries are specifically adding more voltage than there should be in order to get a faster charge. When you charge a battery, you want to do so at a safe rate and apply the safe number of amps to it. We call this the C rate, or the charge rate. A typical charge rate of 1C is considered safe. 2C is typically a fast charging, and anything above 2C can be potentially dangerous. You could determine your C rate by taking the number of milliamp hours and dividing it by 1,000. So this battery, common to radio control devices, is a 7,000 milliamp hour battery. If I divide that by 1,000, I have a C rate of 7 amps. So if I want to charge this battery safely, I should do it at 7 amps or less. We do find when people are trying to charge their batteries much more quickly at 2, 3, and even 4 C rates sometimes, they do in fact get very hot, they swell, they may catch on fire. And that C rate not only applies to charging a battery, but to discharging it as well. I've talked to drone operators, for example, who use so much power from their batteries that they drain them so quickly that they'll catch on fire mid-flight. Now in this example, I'm taking that same 7,000 milliamp hour battery and charging it at a much higher rate than would be considered safe. I'm charging this at approximately a 5.7 C. And what you can see after just a few minutes, the battery starts to swell, it bursts open, and then one of two things are likely to happen. One is it could release an immense amount of smoke. Remember, this smoke is potentially toxic and flammable, and eventually it will burst into flames. or it may burst into flames pretty much immediately, like this example. Another way a battery can catch on fire is through physical damage. If you have enough physical damage to a battery, you can cause the two electrodes to touch, thereby causing a short circuit and essentially a spark inside the battery. Then the battery will start to heat up, likely swell and start to smoke, and very likely can catch on fire. Have you ever wondered why on a plane the safety briefings say that if you lose your device in your seat, please don't adjust your seat? Well, here's a little test I devised to show why that is. If your device happened to be caught in the internal mechanisms of the seat and you caused some major physical damage like this, it's very, very likely to start a fire. Sometimes we see battery fires where we can't exactly determine the cause of the fire. These batteries may have had some sort of internal short, they may have had a previous damage that was gone undetected, and then the battery eventually might catch on fire. But the other thing that we find is that people often try to construct their own batteries in order to give more power to their scooters or their other tools and make their own e-bikes, and oftentimes this is done without the normal safety precautions when a battery is actually built in the factory. Unfortunately, these non-standard build techniques can sometimes lead to a fire within the battery. The other thing that's important to note is as a battery ages, it actually has a higher potential for fire. What's happening is as you charge and discharge a battery, ions are going from one of the electrodes to the other. As they pass through the electrolyte and through the membrane, they contact the other electrode during discharging, and then when they're recharged, the ions go the other direction. Initially, the electrode was very flat, but as the ions return, they don't always lay down as flat as they were to begin with, and sometimes you can start to develop an irregular surface on that electrode. As those ions continue to build and continue to make those irregularities larger, they grow into these spiny projections we call dendrites. As those dendrites grow larger and larger through repeated cycles of discharge and recharge, they can actually grow long enough where they'll pierce that membrane, pierce through to the other electrode, and cause an internal short. That can cause a fire, essentially no differently as if you were to drive a nail through that same battery. So how would you know if your device or your battery is about to undergo a thermal runaway type incident? Sometimes there's no warning at all, but there are a few things we can watch for to let us know that an incident might be about to happen. One is heating of the device. If the device is so hot that you can't hang on to it for more than a few seconds, that means that that battery might be about to go into thermal runaway. Perhaps you'll notice some swelling. As the battery starts to degrade, it can actually puff up or swell to the point where it looks very much thicker than it used to. That might cause the actual casing to pop open on your device, or you'll notice that it just isn't the normal shape. If you ever hear unusual sounds like popping or hissing, that's a sure sign that a thermal runaway might be imminent. Batteries like this essentially have a pressure relief valve built into them that will open up as that internal pressure starts to swell, and you'll hear that audible pop. Then, as the gases are released, there'll be a hissing sound as those vapors rush out of the battery. Or perhaps you'll notice an unusual smell, an electrical smell, a burning plastic smell, something that just isn't the norm. Sometimes your device itself will give you a warning, perhaps a system warning or an excessive heat warning. Sometimes you'll see this when you've just placed it in the sun too long and you need to cool it off for a while, but it also could be an indication of a thermal runaway that's about to happen. So what steps should you take if you think your device is about to go into thermal runaway? First off, stop using the device and set it down. You wouldn't want it to go into thermal runaway while it's in your hands. If you had the device connected to a charger or power supply, disconnect that so that you're not continuing to add more energy to the battery. If you're on a plane, alert the flight attendant immediately. They're trained to recognize the signs of a thermal runaway and act accordingly. And remember, if you lose your device in your seat, or if it's fallen out of sight, alert the flight attendant and do not adjust your seat. Try to avoid touching the device with your bare hands. Find a set of heavy-duty gloves to protect yourself while moving the device. If it's safe to do so, move the device to an area away from other flammable materials. If the device catches on fire, you want to try to prevent it from starting other things on fire nearby. Avoid breathing the smoke or vapors being released from a battery. It's very likely that this is a toxic gas, so you'll want to protect your respiratory tract with some sort of mask or other face covering. If you have one available to you, place the device in a fire or smoke containment bag. This will help contain the device if it does catch on fire and will protect the surrounding area. And of course, if there is a fire event, you'll definitely want to call 911 to alert the fire department as soon as possible. Now let's take a brief look at the fire containment products that Brimstone Fire Protection has to offer. One line is our fire containment bag for personal electronic devices. These are designed for different sizes of devices, 50, 100, 160 watt-hour devices, and has a heavy-duty Velcro enclosure that will keep your device inside, even in the event of a thermal runaway. You can see that these bags are of a heavy-duty construction, heavy stitching, fire-resistant Velcro that is very good at keeping the flap closed. Multiple layers of fire-resistant material so that if that device does go into thermal runaway, it will keep that fire and heat inside the bag. Realize, however, that this bag is designed to trap the fire and heat inside, but not the smoke. There will be a large amount of smoke that can still progress outside of the bag, and remember, that smoke is, again, potentially toxic and very likely flammable. In that case, it might be a good idea to pair the fire containment bag with this smoke containment bag. Again, the smoke containment bags come in a variety of sizes for different watt-hours of batteries, and the design is that you place the device first in the fire containment bag and then in the smoke containment bag. There's a heavy-duty dry bag type zipper that will seal that smoke inside. When a battery goes into thermal runaway, it will release approximately 1/2 liter of gas for every watt-hour. And of course, that amount of gas can change based on the chemistry and the state of charge. So we've done the calculations to ensure that the battery size that you can put inside the smoke containment bag, if it releases all of its gas, will still be contained within that bag. It will inflate to a pretty high degree, but the smoke will by and large be contained within the bag. Realize that the seams are stitched and not heat sealed, so if you were to put the battery at full capacity inside one of the bags and it inflated to its full potential, you might see a little smoke weeping out, but by and large it contains nearly all of the smoke from the battery fire. And as a preventative measure against overinflation, or if someone were to accidentally put too many watt-hours inside the bag, there's a spring-loaded pressure relief valve built into every bag. Rather than the bag being allowed to burst open, this pressure relief valve will vent off the excess pressure and then automatically reclose as the bag releases some of that pressure. Brimstone is also proud to have teamed with Accenture to develop the first and only UL 5800 rated fire and smoke containment bag. These bags are designed to not only protect from the fire of a thermal runaway, but to contain 100% of the smoke produced from that battery. The FAA tested bags from multiple manufacturers, and the Brimstone Accenture bags were the only ones that passed and achieved the UL 5800 full rating. Brimstone also offers a full line of heavy-duty blankets that are designed to cover batteries or devices that are too large to fit inside a bag. These heavy-duty blankets have multi-layers with batting in the middle that can hold up to that intense heat of that battery fire, even if placed directly on the battery. blankets come in multiple sizes for battery packs, batteries on carts, pallet stacks of batteries, etc. And because the smoke being released from a burning battery is very likely toxic, Brimstone offers a respiratory protection mask called the LFIM, Lithium Fire Intervention Mask. These masks come sealed in a pouch and are good for up to a 5-year shelf life as long as they remain sealed. You can also get these masks in a kit with a wall-mountable case that includes the mask and a pair of heavy-duty gloves. I'd like to go over a few preventative measures that will hopefully keep the batteries in a safer condition so that you don't have a thermal runaway event or need any of these products. First off, consider storing your batteries at a lower state of charge if you're storing them for long term. If you don't need them right away, storing them at a 30 to 50% state of charge is much safer than storing them at a 100% state of charge. We find that the amount of gas released is a lot less when the state of charge is less, and the proportions of that gas are actually less flammables and more inflammables. So storing them at a lower state of charge is an overall safer condition. Always use the correct charger for the device, and don't try to trick the charger into giving it a faster charge than it should. Charge your batteries in an area away from other flammable materials, and always monitor those chargers while you're charging your batteries. It's never a good idea to leave the charger unattended overnight or while you'll be away for a significant amount of time. Don't use or try to charge a battery that's been damaged. It's better off to just recycle these batteries in a safe manner. You may have a recycling center in your area that can accept these batteries, or you may be able to arrange to ship them to a recycling center following state and federal regulations. And don't ever dispose of a battery in the regular garbage. This can lead to a fire in the garbage truck or at another facility. I hope that the information that I presented in this video has been useful to you and provided you some information about batteries and the potential for thermal runaway. But more importantly, if you ever are faced with an incident involving the thermal runaway of a lithium-ion battery, I hope the information I've given you will help you deal with that incident in the safest way possible. If you want to learn more about battery safety, thermal runaway, or the entire line of products that Brimstone has to offer, please visit our website at brimstonefireprotection.com.